Good afternoon to Dr. Vicky and also Dr. Lee. Today, my group is going to present about our mini project which we are required to do a casing for the ECG monitoring system. And here is my group. I am the leader of this group, which my name is Chong Ji Hui with the metric number 221151488. And my teammate Beck Yuan, Ying, and also Yushans will discuss about their parts in later. And now I'm going to discuss about my part, which I'm responsible to do the draft designing. So as you can see here is a table which summarizes out three designs in one table. And there is an evolutions and also improvements from draft 1 to draft 3. So let's discuss about it. So for draft 1 is a basic square shape design with the LCD at the upper case and all components will be putting on the bottom case. For draft 2, we introduce a creative design which we use the hexagonal shape to design it. And LCD also at the bottom case, upper case. But then the difference between draft 1 and draft 2 is we add on one cooling system at the bottom of the design. And also the ECG module is not placed on the bottom case, but then is at the side of the bottom case. So for the draft 3 is taking the advantages and idea from the draft 1 and draft 2, and we design it using the square shape, and also we have a cooling system on the bottom case. And also it has some improvement because we put the LCD not on the upper case, but then we put it on the front surface because this is to have a better visibility and also protections. And we have fillet it, and the fillet functions will be discussed later. So here is where details looks for the draft 3, because draft 3 after undergoes many tests is our final decisions to use draft 3 as the casing. And here is a video for my designing. So as you can see in front there is a hollow place which I replace a LCD inside, and if I move out there below there have a hose, and the hose is for the ECG modules connections with the outside. So that's all for my part. And now I will pass the slide to my teammates, which is Beck Yuan.
I'm Beck Yuan and my metric number is 221151479 and I'm from Course Biomed. So I'll be presenting about the analysis part of the mini project. So the analysis part of the mini project can be separated into two parts, which is draft testing and also the material selection. So in draft testing, so there are four types of testing that will be conducted in order to find out that which draft reach our expectations and which draft is the most satisfying. So the first testing is normal compression, which is we apply 1 kilopascal pressure on it. And the second is we change the thermal conditions, that we apply different temperature on it and we conduct the compression test. So the third is we measure the maximum load of each draft can bear it, or each draft can handle. So the same things happens to fault testing, which is we measure the maximum pressure but it's from a side. So moving on to NCs, let me show you that what are the kind of setup that we apply. So this is actually the simple setup for the normal compression, that we apply the 1 kilopascal pressure on the surface, on the top surface, and we have the fixed support at the bottom. So we apply thermal conditions to all the bodies and we conduct the compression test. So next is we use this setup to measure the maximum load, that we apply the force on the top surface and we fix at the bottom. So the force will keep increasing until the draft cannot bear. Same setting happens to fault testing, which is we apply the pressure at the sides and we also apply the fixed support at the sides, and the value of pressure will keep increasing until the draft cannot bear it. So after we apply these four testings, that we find out that actually draft 3 is our best, or is our strongest design. So the result shows that the draft T outperformed the other two drafts. It means that the draft 3 actually perform very well. So the draft 3 can actually withstand a a maximum load of 1038 newtons, and it's actually equivalent to the weight of 105 kg person standing on it. So beside that, so the draft 3 is actually the best and suitable design for the ECG monitoring casing. So the draft 3 combines the advantages from draft 1 and draft 2. So draft 3 retaining the square shape from draft 1 and also introduce the cooling system from draft 2. However, the location of LCD is different from draft 1 and draft 2, which is the LCD is located at the sides, and this actually gives uh, more convenient to users, and also it provides extra protections to it. So after we deciding the draft that we needed, so we will move to the second part, which is the material selection. So at material selections, we have spotted out that there will be 6 different types of materials, which is polycarbonate, PET, ABS, PE, PP, and HPDE. So these 6 materials actually reach the requirements of electrical insulator, shock absorption, temperature stability, and also light in weight. So after we decide the material, so we will continue the testing on the we will use different material and undergo testing one by one. So the result will be presenting by my teammates. Thank you very much. That's all for me.
We will continue part 2 discussion. Polypropylene was chosen as an optimal material for the casing due to its superior performance in compression tests. PP exhibited low maximum total deformation, low maximum equivalent stress, and low maximum equivalent strength in ANSYS simulation. By comparing the graph and data, we found that polypropylene matched our target goals and reached our expectation. Maximum total deformation value show the distance of the object deformation after a certain load. Lower value indicate less deformation. Maximum equivalent stress indicate the highest stress an object can withstand before failure. Higher value implies greater compressive load capacity. Maximum equivalent strength show the maximum deformation an object undergoes before failure, represent the ductility of the material. Ductility, property of a material to undergo deformation through stretching or compressing before fracture or failure. Higher strength value indicate more deformation before fracture. Next, stress and strain analysis. Stress-strain analysis conducted to evaluate the suitability of the selected material. Stress-strain curve provide insight into material strength, stiffness, and other properties. PP has a favorable location on stress-strain graph, indicating its ability to withstand greater compressive load before failure. PP shows lower maximum equivalent stress and strain value, minimize deformation and structural damage to electronic components. Maximum pressure calculation. Maximum pressure the design can hold before fracture is 0.35 MPa. Maximum stress value at 0.68 MPa pressure is 151.41 MPa. Maximum strength value at 0.6 at MPa pressure is 0.041795. Body casing is suffering from 33.964 MPa. Maximum stress is located on the protective layer. 0.35 MPa is the highest pressure the design can hold before the protective layer fracture or damage. Ultimate tensile strength of PCB laminate FR4 is 29 MPa. Tensile strength of PP is 37.62 MPa. Next, selection of the protective layer. PCB laminate FR4 was chosen as the protective layer for draft 3 LCD. Factors considered in the choice of PCB laminate FR4 include electrical insulation to prevent short circuit and ensures user safety, shock absorption to protect fragile electronic components, stability under changing temperature essential for military deployment in hot and dry areas. Next, polypropylene chosen as the optimal casing material for the ECG monitoring system. PP exhibits superior performance in compression tests and can withstand significant force and pressure. Positive stress strength graph indicate its stress and elasticity. FR4, a PCB laminate selected as a protective layer due to its high ultimate tensile strength. The combination of PP and FR4 ensure durability, functionality, and safety of the ECG monitoring system.
So now I would like to proceed to the last part of our mini project presentation, which is conclusion. In conclusion, the development of the ECG monitoring system casing involved two major phases, which is designing phase and analyzing phase. In designing phase, moving on to this, we prepare three draft design, which is draft 1, draft 2, and draft 3. Moving on to the analysis phase, all three drafts undergoes some test through and seek to get the best design among them. Various tests has been applied such as compression tests and compression under certain thermal conditions. Surprisingly, draft 3 can afford 1038 Newton, which is equal to 109.5 kilo and which produce a maximum stress of 62.77 MPa. So draft 3 is chosen to proceed to our next phase. And in the next phase, we'll test the draft 3 design with various materials such as PC, PET, ABS, PE, PP, and HPDE. So in analyzing phase, after various of testing, we found that PP and PCB combination is the most suitable material. It shows the low maximum equivalence stress and strain value, and this matched with our expectation. In addition, PP can maximally afford 0.35 MPa pressure and produce 33.964 MPa on the body casing, and maximum equivalent stress is 151.41 MPa, which is located a protective layer. In summary, the design of draft 3 with the material of polypropylene as the body casing and PCB laminated FR4 materials as the protective layer will be finalized decisions for the casing for ECG monitoring system. So that's all for our presentation. Thank you.